Now let's look at reverse separation drilling method. The reverse separation drilling method usually uses a dual wall drill rod. Compressed air is pumped down the outer annulus, then the cuttings are returned to the surface through the inner tube. So this one is reverse compared to the air blast uh, method that we used. Okay, so let's. Oh, I'm coming. Let's say this is our drill hole. Okay, and this is our rod, drill rod. Okay, so at the bottom here we have the drill bit. So what happened here is that the drill rod has an inner tube. There's an inner tube here. Pardon me, I'm trying to make a drawing for you. Okay, so it has two. So let me use this one. This is uh the drill hole. Okay, and we have the drill rod and the drill bit. Let's say the drill bit is somewhere here. Okay. Now the drill bit has two. There are instances where the drill bit will have one hole, like an inner hole inside, and there are instances whereby the drill bit will have an inner hole and an outer hole. Okay, so I'm supposed to draw the outer hole, but it's not permitting. So this one instance, the compressed air actually forces the cuttings through the inner hole. So it means that you have a compressor on board that will force air from the outer. Uh, it forces air through the walls of the drill hole and also the rivet or the drill hole and the drill rod. So when it gets to the bottom of the drill hole, it passes through. We have some nozzles at the base of the drill bit where the compressor or the air will pass through. So when it is passing through, it comes along with the cuttings through the inner hole, okay, and it is received on the surface. But there is also an instance whereby we have the outer hole and also the inner hole. So in this case, a compressed air is actually falls down through the outer hole into the small into the drill hole. And when it gets to the drill hole, it mixed up with the cuttings. Then it is received through the inner hole. So Uh, I couldn't draw the outer hole. Let me do this one. So let's say this is the outer hole of the drill rod. Okay. So the air will pass through this outer hole down into the drill hole. When you get to the drill hole, mixed up with the patterns that are within the drill hole, then it will now be received upward through the inner hole and be received at the surface. Okay, so that's why we call it uh, reverse circulation. When you compare it to the rotary air blast circulation, you can see that this one is a reverse of the rotary air blast circulation. The rotary air blast circulation, air is blown through the whole of the railroad. When you get to the base of the drill hole, blows the air out through the holes between the walls of the drill hole and also the drill road to the surface. But in this case, air is received into the drill hole, then it is uh, blown out through the holes, the inner hole of the drill rod, the drill bit, and received upwards. Okay, so air coming down like this through the outer walls of the drill rod, then it can now pass through the inner rod and receive upwards. I hope you guys understood this one. But there is a diagram below. I will show it to you as we are going. So it's best for deeper exploration in medium hard to hard rock. So when we are dealing with a formation that is medium hard to a formation that is hard, you can use the RC for such drilling program. Provides better sample qualities than the RAP, that is rotary air blast drilling method. Okay. So this is what I was trying to explain to you. We have an instance whereby we just have one hole in the drill rod or the drill bit. Okay, so this is one hole in the drill rod and the drill bit. So this is a drill bit, this is a drill rod. Okay, so air is forced into the base of the drill hole, and when it comes, it carries along it the patterns within the drill hole. Then it is received upward through the inner hole of the drill bit, the drill hole. Then it is received as a sample of the surface. Okay. So this is how you can see it. So this is the aneurysm hole between the walls of the drill rod or the walls of the drill hole and that of the drill rod. So, and this is the inner hole drill rod. So, and there is also an instance whereby the drill rod will actually have two kinds of holes. We have the inner hole and the outer hole in the same drill rod. So air is forced down through the outer hole of the drill rod, then it is received through the inner hole of the drill rod. So this is the outer hole of the drill rod, and this is the inner hole of the drill rod. So the air is coming down, and it is going out through the inner hole of the drill rod. I hope this is clear now. What are the advantages and disadvantages? For advantages, it has faster penetration rate than the core drilling, with a better sample quality than rapid or the rotary air blast drilling. Has less contamination when compared to the rotary air blast drilling. Can reach greater depth than the rotary air blast drilling. Typically, is greater than 500 meters below surface. And so we can drill up to 500 meters when we are dealing using the house. What are some of the limitations? It's more expensive than the rotary air blast drilling. They can charge, uh, let's say, We charge normally charge meter per dollars per meter depth of advancement. Okay, so that is at every 1 meter they can charge you, let's say, $50 to $100, and even more. Compare that is with respect to the depth where you are preaching. Okay. Sample contamination can still be an issue. Yes, the instance whereby you are dwelling within wet zones, within a wet zone, then the sample contamination can be an issue because this sample is not in core. Okay, it's coming as dust or it's coming as fragmented material. So we can actually experience contamination. It's not suitable for fractured or unconsolidated ground. That is, in this case, we are using compressed air. So we can, in unconsolidated ground, we can still face challenges. Common application, it can be used in delineating mineralized zones. When we want to find the boundaries of the ore body, we can use the RC drilling to do that. It can be used for testing deeper exploration targets. For the initial testing of target zones, we can use the air blast method. But when we want to go deeper, then we have to bring in the RC drilling method for such a rig. Can be used for geological mapping and initial resource estimation.